Hi, good morning, students. Welcome back. I'm happy to see you all again. Today, we are going to continue our physics session. That's refraction of light, especially refraction of light through a glass slab. We already discussed about the refraction of light when it travels from air medium to denser medium, like air to water or air to glass. And today in this session, we are going to focus on how we can draw a refraction of light through a glass slab. Before that, we can just go through the previous classes, what we studied in that classes. Actually, when a light ray travels from a rarer medium to denser medium, especially suppose it was traveling from air to water. So when a light ray travels from air to water, air is a rarer medium and water is a denser medium. So when a light travels from air to water, what happens? Before that, we have to draw a normal here. Okay, clear. So what happens to this ray? You can see that this ray bends towards what? Where actually the different directions are there, chances are there like this or like this. But you know that it is it travels from air to water, that means from a rarer to denser, and the angle of incidence I, here it is I here, and r is here. The angle r is less than angle I, because this line bends towards the north. So this is the diagram for that. When travel from a rarer to denser medium, I think that's clear. Okay, are you ready? We are going to discuss about the light refraction through a glass slab. For that one, first we have to draw a glass slab. How we can draw a glass slab? Simple. A rectangle. If you draw a rectangle like this is a glass slab. You must remember one thing. This is a parallel sided glass slab. That means its sides are parallel. This side and this side. This side and this side. They are parallel. Clear? So when a light ray falls from air to this glass. So which media is air? Here this media is air. This media is glass. Okay. This one. And down this is air. Okay, when a light ray travels from air to glass, as we discussed earlier, this ray will bend towards the, if this is the incident ray, we have to draw a normal here. This is this is the normal. Okay, so we can see that this light will bend towards which direction? Towards this direction. Okay, clear? So two angles are here. First angle is here, the first angle. This is the angle of incidence, and this is angle of refraction. Okay, up to this, I hope it's clear for you. But You have to extend this line. For what purpose we are extending is this line? If suppose if the glass slab is not here, then this ray will travel like this. Okay. So what's the use of that one? That we can discuss later. So this line, make it as a dotted line. Make this as a dotted. So this one. Okay. Then we have to draw one more normal. Where we have to draw that normal? Here we can draw this normal. Here. This is the second normal. If you look at here, you can find that this ray is going from glass to air. Glass to air. So this is from rarer to denser. Clear? This ray is now traveling from rarer to denser. That means this ray will move away from the north. Move away from the north. But this also, there can be different chances. But you should know one thing. These rays must be parallel, which rays this old ray. That means this one. This extended ray and this one make this as parallel lines. Clear? This must be parallel. Again we can mark one more angle. Where's that angle? Here one angle, here another angle. So if this is I, we can write this as I dash. Okay, so this incident ray is I dash. And this angle we can mark it as angle of emergence. That is E. Now we can draw the directions. This is like this, going here and this way. Now we can observe one more thing, that there's a shift. What do you mean by shift? The emergent ray is going like this. And you check with that one, the incident ray. When you extend this incident ray, you can find this. That means there's a shift. There is a shift. How much? From here to here. I'm going to mark that. The shift. From where to where? This is the shift you can find. For this, we are using a term called lateral displacement. What is this? This is lateral displacement. So this is the ray diagram for a light ray when passes through a glass slab. Clear? So what are the things you must remember? So the angle here is one angle, that's angle of incidence. This is the angle of refraction. Here is the angle of incidence again inside the glass. This is the angle of emergence, and this is the lateral shift or D. You have to remember this one. Make this as parallel. This one, make these lines as parallel. No need to draw like this, but just remember that these lines are parallel. Now we can mark this triangles and this rectangles A, B, C, D as a glass slab. We can give different English letters like A, here B, you can write here C, here D, you can write. So at that way, what is AB? What is AB? AB is the incident ray, and BC is the refracted ray. Here also, from C to D also. That is refracting. And there are different angles also. We can use a protractor for measuring here this 90 degrees, but that's not necessary. Without that also, you can draw this in a nice way. I hope you enjoyed this class and practice this more and more. Use a ruler, always use a ruler and draw neatly. Have a nice day. We can meet again next session. Thank you.